starting starting 6.6. Your endocrine system is all about hormones, and that's what they release. So that's what that blank is. And they move around in your blood. Remember, hormones are another way for your body to communicate with itself, like the nervous system is there to communicate with other parts of your body. And homeostasis is a fancy way of saying balance. So you're trying to keep your body in balance. So, like blood pH, you want to keep, just slightly basic. Carbon dioxide, so CO2, carbon dioxide limits, blood glucose, body temperature, sure. And then, what do you think this is? Very important on a daily basis. I know you think about this. I see you guys drinking water in class, so you're trying to keep your water balance right, not get dehydrated. So you want to stay within a normal range, and that's slightly different for every person. But your body has that set point, and we'll keep it. For example, like 98.6 degrees Celsius or Fahrenheit is your body's internal temperature, but people can be a little bit above or a little bit below that. That's just an average. So your temperature might be different. But your body, it will act to increase a variable that gets too low. For example, your temperature gets too low, it wants to increase it, and decrease one that gets too high, so cool you down if you need to. And that's the way a thermostat works in this room. It gets too hot, it senses it, and puts on the air conditioner. If it's too cold, it's like 50 degrees in here. When I get here, turn it on, it's going to turn the heat on until we get up to 72 degrees. So if you remember what I just said, here this thermostat says 72 degrees. What would your body be set at? Probably somewhere around 98.6 degrees, not Celsius, Fahrenheit. You're about 37 degrees Celsius. That's what you would have if you had set on your body. Okay? And to control that temperature, if your body is too cold, wants to increase it, it's going to start to shiver. That's going to burn more ATP. Your muscles are going to work more and make that heat. And where should the blood go? If you're trying to preserve your temperature, your heat, you want to go to the middle of the body. So your trunk, you don't want that near the skin. Your hair stands up, and that creates, so this is your skin, the hair stands up, that gives you a little layer of air here. It can act as an insulator. Normally, this is your skin. Your hair is lying flat. It's not much of a layer, so you want to increase that protective layer. And then also, your body might increase insulation. If you want to decrease vasodilation, you can see that in somebody's face when they get hot. They look flushed. They look red. Or if they're embarrassed, that happens. But that's a vasodilation. Capillaries. Capillaries expand. That's what I'm looking for. They swell. That's still not the best word. I'll come back to that. Sweating is something you do when you get hot. It's very effective at cooling you down. And you want to slow down the amount of work your body is doing, because work is creating that extra heat. So the fancy word for burning calories, can you guess? Metabolism. Okay? And blood directed towards the arms, legs, and head, because that increases surface area. All right, surface area coming in again. So you're increasing the amount of surface area your blood's being exposed to, so that heat can be released to the outside, the atmosphere. And blood is used to move heat around. Kind of like how on Earth, the oceans, getting real laggy here, oceans move heat. Your blood is kind of like your internal ocean, moving that heat around. For the Earth, the ocean's moving that heat. And we'll look at this place called the hypothalamus. It controls how your body responds to temperature. If your temperature increases, the hypothalamus is going to send more blood to the skin and start to sweat. And if it decreases, it will tell the body to keep that blood in the middle and start shivering. And you can see right here, very central to your brain. If you look at all this area of the brain here, this is like mission critical area. So very critical, this central part of your brain. This part here is important too, or actually not this part, but this part, this is where you're high functioning, where like when I'm trying to do this and teach you, you're trying to learn, you're using this area of your brain. Just getting by day to day, your body's staying alive. You're looking at this part of the brain controlling all parts of your body. And we've probably talked about diabetes here. You've heard of insulin. If you have too much glucose in your body releases insulin, and those are your beta cells, and that makes your body cells take in more glucose. So it comes out of the blood, so your blood glucose level is lower, and that sugar gets into your blood. And since you have extra sugar, your liver is going to take that glucose, turn it to glycogen. Remember, glucose is a monosaccharide, and then glycogen is a polysaccharide. So it's going to have lots and lots of glucoses stuck together. So polysac. This is monosaccharide. If your body also get too little, like you wake up in the morning, feel hungry, you haven't eaten all night, your blood sugar is going to be low. So you're going to need another hormone to deal with that, and that's called glucagon. Glucagon, sorry about the handwriting there, glucagon. And that comes from your alpha cells. So remember, beta cells for B-I-A-G. B-I-A-G. Beta cells, insulin, alpha cells, glucagon. And that'll make your glucagon tells the liver to take that glycogen and turn it into glucose, dump it into your bloodstream so you can have your blood sugar raise up or increase. So insulin, talk about the two different types of diabetes. I know you've heard of these, but type 1, you have it from birth, and you just have high blood sugar. Usually caught pretty early, extreme thirst and sluggishness. But what happened is the person's own body is an autoimmune disease, and it destroyed, you remember which cells? Beta cells. So the beta cells, of course, are the ones that make the insulin. And they either don't make enough or not any insulin. And you control by monitoring what you eat. Not to eat anything that's going to spike the blood sugar too much, and at appropriate times taking insulin, which used to come from cows 30 years ago, now come from bacteria. And it can make a lot of cheap, good, very high quality insulin with bacteria. Probably the best thing to happen in the revolution in biotechnology in the 70s. They were able to stick genes from one organism like us into bacteria. Took our insulin gene, put it into a bacterial gene, grew that bacteria, and the bacteria makes insulin for us. So type 2 you've heard about, and that's kind of the public health issue right now. It's called adult onset, but children can get it. Okay, and it's caused when these insulin receptors on your cells don't respond properly to insulin, so they won't accept that glucose into the blood. They'll just leave it out. Even though the body's making plenty of insulin, it won't be absorbed. And it's linked to increased body weight, and it can be controlled with proper diet, weight loss, and exercise. And these are all very simple things, but are difficult to do. Okay, food is so powerful these days, the way it has engineered to taste so well, taste so good to us. It's tough to control diet. And then weight loss, some people just have a really tough time with their metabolism. Exercise, that can be difficult to include in your day. So those are all simple things, but are very effective if they can be implemented. And if you look at all these side effects of diabetes, they're just devastating. Kidney failure, you'll die without your kidneys. You'll have to do dialysis, which is a terrible way. It's just terrible. You have to go in 3 times a week. It takes several hours to clean your blood. Blindness, of course, that's terrible. Nerve damage, not being able to feel parts of your body, heart disease, gangrene, amputations. So think about losing, a foot, a hand. That happens with a lot of people that have unchecked diabetes. So really important to get that under control. So we talked about hypothalamus earlier, right there, pineal. Another really important pituitary gland. It's also very middle of that midbrain. It's going to have a lot of effects on the hormones that we're going to learn about here. Sitting right on top of your kidneys are your adrenal glands, and as you can probably guess, they make adrenaline, that hormone that gets your body going, gets your blood pressure going, your heart rate up, gets you ready to fight or flight, either fight or get out of there. Sitting behind your stomach, right there, is your pancreas. And right here in females is the ovary, and there in males, the testes. Okay? And here's a flow chart. What happens, if you can identify this right here is your thyroid. Right here in your neck is where your thyroid gland sits. But your pituitary gland controls that. Pituitary gland. This stands for thyroid releasing hormone. Goes to your anterior pituitary. So this communicates with this, then releases thyroid stimulating hormone, which creates these 2 thyroid hormones. And both of them, if you've got a lot of them there, they'll do this negative feedback. So negative feed. I did have more space. So negative feedback, it'll tell the pituitary to slow down. Same thing with the anterior pituitary, so you don't get too much there. And that's how most of your body systems work with negative feedback. You have a lot of a hormone, your body doesn't want more, so it'll shut down production to stop wasting hormones.